December.
So, okay. Okay. So we are talking about the correlation and okay, regression analysis. So this is the topic we are discussing. Okay. Correlation గురించి మనం చెప్పుకునేటప్పుడు okay, so as we discussed correlation in the last class, so generally we discussed about the different types of the correlation, like positive correlation, okay, negative correlation, linear correlation, non-linear correlation, correlation, simple correlation, multiple correlation, partial correlation, and total or complete or full correlation. Okay. Okay, simple correlation, nothing but if we are explaining the relations between only two variables, so that will be called a simple correlation. Actual correlation, nothing but the relation with two or more than two variables. Okay, if we are explaining the relation between only two variables, that is called simple correlation. If the relation is explaining among the more than two variables, okay, among more than two variables, that will be known as the what is called multiple correlation. Okay, that will be called multiple correlation. Okay, partial correlation, nothing but already so I told you in the yesterday class partial and complete correlation. Okay, friends, in today's class, okay, we are going to discuss the methods of the study of the correlation. Okay, in the last class we discussed about the classification of the correlation or types of the correlation. In the today class, we are going to discuss that methods of the studying of correlation. That means what are the methods we are using to estimate the correlation. Okay, what are the methods are going to be used to estimate the correlation. So that is we are going to be discussing this today class. సహసంబంధమును అంచనా వేయడానికి ఉపయోగిస్తున్నటువంటి పద్ధతులు ఏమిటి అన్నప్పుడు, so there are different type of methods are there to estimate the what is called correlation. There are various methods of studying of the correlation. చాలా పద్ధతులు ఉన్నాయి, but these methods are broadly classified into two types. Whatever the methods we are using to estimate the correlation, okay, that methods broadly divided into two classification, two categories. So one of the thing is like a graphic method. Okay, so there are various methods. Among them, one is graphic method. Okay, graphic method, and the second is like algebraic method. Okay, that is a mathematical method. Graphic method ఒకటి, mathematical method ఒకటి. Okay, that mathematical method is known as the algebraic method. So these are the two methods we can see. So one of the method is known as the graphic method. Graphic method. So in this graphic method, we have the diagram method and scatter method. Diagram method and scatter method we can see. So here, diagram method. Okay, diagram method. You know, diagram. ఎవరు బాలాజీ? బాలాజీ ఎవరు? మ్యూట్ చేసుకోండి, డోంట్ అన్మ్యూట్. Okay, diagram method. You know, in economics, almost most of the things are going to be explaining the diagram method only. It is a simple method. Okay, simple method. So, for example, you take example demand chapter. Okay, in the demand chapter, you know that the demand is going to be measuring on the OX axis. OX axis, and the price is going to be measured on the OX axis. OX axis. So if this is the price, the demand, this is the demand for the commodity. According to demand theory, if the price increases, the demand decreases. If the price decreases, demand is going to be increases. If we add all these points, this will be called the demand curve. Okay, the demand curve. So this point we know. So what is the slope of the demand curve? What is the slope of the demand curve? So the slope of the demand curve, okay, demand curve is negative slope. Okay, negative slope, we know that. So already, as we discussed in the last class, what is the relation, what is the correlation between price and demand? Negative correlation. So as we discussed like that. So that's why in the diagram, based on our observation, based on the visibility, so based on the line in the diagram, we can say what type of the relation is there between two variables. There are two variables here, price and demand. This is the price, this is the demand. This is the independent variable, this is the dependent variable. Okay, based on the slope of this curve, we can explain the relationship between these two variables. That is, we can say that there is a negative relationship is there between price and demand. Otherwise, we can say that inverse relationship is there between price and demand. So like that. Suppose if this is the curve in the diagram, so this shows that if this increases, this is also increasing. This increases, this is also increasing. If this decreases, this is also decreasing. We can see the supply curve like this. Okay, in a microeconomics, we can see the supply curve. So where the price is measuring on the OY axis, where the supply is measuring on the OX axis. So this is the supply curve. When the price increases, supply also increases. When the price decreases, supply also decreases. So we can see that positive relationship between price and supply. Okay, price and supply. So like this. Okay, like this, based on this one. Okay, based on the diagram, we can observe that what type of the relation is there between two variables. Okay, if based on this, if any line in the graph will coming from downward slope from the left to right, so we can say that negative relationship. Okay, negative correlation. So if the line is going upward slope from the left to right, we can say that positive relation or positive correlation between the two variables, we can say. Suppose this is the line. Okay, that means, so here we can say that perfect elasticity, something like that. Okay, this is called a diagram method. Okay, in the diagram method, based on the observation, immediately we can say that what type of the relation is there between the two variables. So that is one method in the graph method, and the second one is scattering method. Okay, scattering method. Scattering method, nothing but it is also graph method. In the graph, instead of the line, instead of the curve, we can see the dots. Dots will be scattered in the diagram. So, see, for example, this is the thing in the graph. Okay, yeah, all the points are going like this. So that means moving upwards. All the dots are scattering up towards upwards. So it shows that positive relation. Okay, positive relation. So otherwise, in the diagram, okay, in the diagram, if all the dots is coming down like this, something like that. So this shows that a negative relation, negative correlation. So negative correlation. So like that, in the graphic method, we are going to be explaining the relations between two variables. Okay, how the dots are scattered in the diagram, in the graph. Based on that, we can explain the relationship between the or among the variables. So that's why it may be diagram method or scattering method. The both are called graphic method. So in the graphic method, okay, in the graphic method, if the lines are moving upwards, we can say that a positive relation, positive correlation. So if the lines are, the dots are coming down, downward slope, that is called a negative slope. So like that we can explain the things, what we can say. Okay, this is the one of the method. And after this graphic method, the second method is algebraic method. So this is known as the mathematical method. Okay, mathematical method, what we can say. Algebraic method or mathematical method. This is the most important method to estimate, to measure the correlation between or among the variables. So this algebraic method are based on the mathematical formula. That's why I told you it is called mathematical method. So in this method, we are estimating, we are computing the relation among the variables based on mathematical formulas. Okay, based on the mathematical formulas. Okay, the relationship between, so the relationship can be expressed by the coefficient of the correlation in the range of plus or minus. Okay, if there is a plus value, we can say that a positive relation. If the value is in the negative, we can say that there is a negative relation. Positive relation, negative relation. In the diagram or scattering method, if the line is moving upwards, we can say positive relation. If the line is coming down or a downward slope, we can say that there is a negative relation. That is graphic method or diagram method. But in the mathematical method, based on the mathematical formula, we are explaining the relation between the variables. So if we will get the positive value, so we can say that there is a positive relation between the variables. If we will get the negative value, so then we can say that there is a negative relationship between the variables. So that's why the coefficient of the correlation in the range of the plus or minus. Okay, either positive or negative. Positive relation, or we can say that a negative relation. So the relationship is expressed in accurate terms. Exactly how much relation it was there. What is the value? Okay, so take for example 0.67. The relation, this much value is there. Or we can say that minus 0.67 means negative relation. This is the plus 0.67, nothing but a positive relation. Like that, exactly what is the relationship between these two variables, we can estimate, we can measure. Okay, we can measure the among the variables, exactly accurate values we can. Okay, so like so the relationship between is expressed in accurate terms as not be guessed by the visual inspection like graphic method. So if it is the graphic method, we can estimate by visual, by inspection, by observing the diagram. But here, not based on the observation, not based on the visual, not based on the inspection, okay, not based on the observation. So it is based on the mathematical formula. We are going to be estimating exactly the value, the accurate value. So here, in this algebraic method, in the mathematical method, to measure the correlation among the variables, there are various type of the methods. Out of them, the popular methods are called Karl-Pearson coefficient of correlation. This is the one of the important method. And the rank correlation or rank deviation. Rank correlation or rank deviation. So this is called Spearman rank correlation. This is called Karl-Pearson coefficient of correlation. The second one is called Spearman. Okay, the Spearman rank coefficient of the correlation, and concurrent deviation, that is concurrent correlation, and least square method. So these are the four important methods are there. But out of these four important methods, the first two are there in our syllabus, which we are going to be discussing now. Karl-Pearson coefficient of the correlation and the Spearman rank correlation. So these are the two methods are there in our syllabus for the calculation to estimate the what is called correlation. So the first one is Karl-Pearson coefficient of the correlation. Okay, the Karl-Pearson coefficient of the correlation. So it is a mathematical method to estimate the correlation. What type of the relation is there between two or more than two variables? So this method is one of the important popular method. So it was developed by Karl-Pearson. Karl-Pearson was developed, that's why it is called Karl-Pearson coefficient of the correlation on his name. So he belongs to Britain, biometrician. Okay, he was developed this relation, and this method is most widely used in the practice. So in the correlation, so this method, the Karl-Pearson coefficient of the correlation, the method is widely accepted, widely used in the practice. Most of the people are using in the practice. So it is denoted the symbol called R. Okay, small r nothing but Karl-Pearson coefficient of correlation, that is r. So this is the r. E asserts that the value r must be between plus or minus. Okay, plus either positive value or in the negative value. Okay, that too, plus or minus 1 we can say exactly. Plus or minus 1. Okay, if it is there in the plus positive value, we can say that there is a positive relation. If we will get the negative value, we can say that there is a negative relation. Okay, that value in between, so plus or minus 1. Okay, that means either it will be so minus 1 or plus 1. In between only it will be there. Not more than the, not less than the minus 1, not more than the plus 1. If the correlation value we will get either less than minus 1 or more than plus 1, so we can say that there is a wrong calculation. Something went wrong. So the result was wrong, we can say. Okay, that's why according to Karl-Pearson, the coefficient of the correlation among or the between the values, the variables, always in between minus 1 to plus 1 only. Highest value may be plus 1, the least value may be minus 1 only. So in this in between only the value will be there. Okay, that's why. So his interpretation of the different values of the R are like the following. Okay, always see, already I told you the R value. Okay, R value, that is Karl-Pearson coefficient of correlation. The value in between minus 1 to plus 1 only. Okay, please remember this one. Always the value is in between these two only. Okay, when the value is in between the minus 1 to the plus 1, then how he was interpreted? Because we know that in this mathematical formula, in mathematical method, in the Karl-Pearson coefficient of the correlation, so we can know the accurate value to estimate the correlation between two variables. Okay, based on that value, what type of the relation is there? What type of the correlation is there? How strong the relation was there? We can estimate. So based on that, he was interpreted the values like this. Okay, like this. If R is equal to 1, that is called a perfect positive. Okay, R is equal to 1 nothing but it is a positive value. So that's a positive relation. Okay, positive correlation we can say. But how much it is positive? Perfect, complete. Perfect means complete. Complete. So if R is equal to minus 1, it is called a negative value. Always the lies between these two only. Okay, it is a negative correlation. Since we got the negative value, we can say negative relation. How much it was there? Perfect, complete. If it is equal to 1, it is called complete. The both are called perfect correlation. Okay, plus 1 and minus 1, the both are called perfect correlation. If we have the positive value, then perfect to positive correlation. If we have the negative value, then only it is called a perfect negative correlation. What we can say. So if the R value is more than 0 and less than 1, okay, that means in between 0 to 1. Okay, if it is in between 0 to 1, okay, we can say the positive relation but not perfect. That is called imperfect positive correlation. Since we got the positive relation, we got the perfect correlation, positive correlation. But it is not equal ratio. Not equal ratio. So since it is not equal ratio, it is called imperfect positive correlation. So if the value is in between this one, like the value is -1 to 0, -1 to 0. Okay, nothing but it is called negative value. So negative value, nothing but it is called negative relation, negative correlation. But it is not equal to 1. That's why it is called imperfect. If it is equal to 1, perfect. If it is not equal to 1, it is called imperfect, unequal. Okay, positive value, positive correlation, negative value, negative correlation. So both is called imperfect correlation only. Why? In case of the first two, the value either positive or negative, there is exactly 1, either +1 or -1. That's why perfect relation, perfect negative, perfect positive. But here it is not equal to 1, not equal ratio. Less than 1. Okay, so since it is not equal ratio, it is called not perfect. Not perfect, nothing but imperfect. So imperfect correlation. So if the value is more than 1 or less than 1, already I told you, always lies between either a +1 or -1 in between only. If the value is varies from these two, that means so the erroneous, that is wrong result. So that cannot be estimated. So that is not at all correct method. Okay, if the value is nearly more than or equal to 0.90. Okay, 0.90, nothing but it is a positive value. Okay, positive value. But it is near to 1. That's why very high degree of correlation. For example, if it is plus 0.9, very high degree positive correlation. Very high degree positive correlation. So if it is minus 0.9, means it is a very high negative degree correlation. Negative. So that is, if it is in between 0.75 to 0.9, called fairly high degree of correlation, positive or negative. If it is positive, positive correlation, or if it is negative value, negative correlation. Okay, yeah, if it is the value is in between 0.5 to 0.75, the moderate degree of correlation. Moderate degree of correlation. So if the value is in between 0.25 to 0.5, we can say that low degree of correlation. It is the relation is there, but low degree of correlation is there. Okay, like if the value is less than 0.25, so it is called very low degree of the correlation. If R is 0, nothing but there is no correlation. Means R is 0, nothing but when the independent variable is changing, the dependent variable is not at all changing. So when the both we can say that both are independent variables, both are separate variables. When both are having the separate called separate variables, we can say that there is a absence of the correlation, which is called no correlation. What we can say. So that's why here, whenever we are talking about this relation, see, for example, we can see, okay, the price of commodity, the demand of one commodity. Price or demand will be like this. When the price was changed, okay, the price was changed like 20%, but the demand was increased only 10%. The demand was decreased only 10%. So we know that price elasticity of demand is equal to the change in demand divided by, okay, change in price. Change in demand is 10%, whereas change in the price is 20%. That is equal to 0.5. Okay, 0.5 nothing, but there is a relation between this price and demand. But what type of the correlation is there in between? The moderate correlation is there between these two variables. So like that, so we can estimate the variables based on the value. So suppose it is called minus value. Okay, so the price and demand, you can say if it is we will get the minus 0.5, we can say that a negative correlation. Okay, negative. Suppose we got the R is equal to 0.39. This is it positive or negative? 0.39 nothing but positive. Okay, positive relation, but the degree of correlation is low. So if it is 0.5, less than 0.5, we can say that low degree of correlation. Suppose the R value is 0.9 minus 0.92. Let's say example. Okay, since it is about 0.92, we can say that manaku very high degree negative correlation, because we got the negative value, no? So negative correlation nothing but one increases, another is coming down. And please remember, negative nothing but if one variable is increasing, another variable is decreasing. That's all. Positive correlation nothing but one variable is increasing, another variable also increasing. That's all. That is the only variation between these two. Negative and positive nothing but. Okay, so that is we can say. So if R is equal to 0.72, we can say that it is more than 0.5. So we can it is in between 0.5 to 0.75. It is called what we can say moderate degree of correlation. Moderate degree of correlation, exactly. So is it a positive value? Means one variable increases, another also increasing. That's all. Okay, like that, based on the value, we can say that what type of how much strong relation is there between two variables. How much strong relation is there between two variables, so that we can see here. So there are two broad categories of the formula which can be obtained by direct method and indirect method in case of the Karl-Pearson. Okay, in case of the Karl-Pearson coefficient of the correlation. So we can estimate this one through direct method and indirect method. Through direct method we have separate formula, through indirect method we have separate formula. Okay, this how by using this Karl-Pearson method, how the correlation is going to be explaining between the variables through this method. So we will discuss tomorrow class. So if you have any doubt, please ask me on this class.